Hello friends, in this part of the video for Differentiation 1 for mathematics preparation for IIT JEE exam, we will discuss some important examples for continuity and differentiability. In the previous videos, we discussed very simple examples which were just to give you a taste of how to approach these problems. In this part of the video, we will do some more real JEE type problems which will be definitely useful for your preparation. So one of the questions that I want to discuss here, the first example, is that we have been asked to discuss the continuity and differentiability of a function fx, which has been given here, minus 1, minus 2, less than is equal to x is less than equal to 0, and then we have been asked x minus 1, x is greater than x is greater than x and less than equal to 2. Okay, so this is the function we have been asked for fx as given as a function, but we have been asked to find the differentiability and continuity, discuss the differentiability and continuity of gx is f mod of x plus mod of fx. Alright, so we have been asked to find the differentiability and continuity of a function like this. So how do we approach a problem like this? So one way is to approach the problem using LHD and RHD, which is perfectly fine. However, like I have said, whenever you see something which is possible to sketch, and you should have enough practice because the functions chapter, that you should just quickly sketch it, because you can do that mathematically, but that might take a little more time. So let us just very quickly try to sketch. Can we sketch it very quickly? So if we have fx, let us first sketch fx and then we'll try to sketch gx. If we have fx like this, then minus 1, so this is, let us say, minus 2, this is minus 1. So you have been given the value as minus 1 for both of them, from here to here. And then you have been given that x minus 1 between 0 to 2. So if you put x minus 1, put 0, this will be minus 1, and then if you put 1, it will become 0, and if you put x equal to 2, y is equal to 1, so this will be something like this. So the y is equal to 1 here, 0, minus 1, right? This is the value for, so this is x equal to minus, y equal to minus 1, and this is y is equal to x minus 1. I hope you were able to follow this very quickly. Alright, this is the graph of f of x. Now f of mod x means that you are, whenever you put a negative x, then it will make it a positive function, right? It will make it just as positive. So in other words, whenever you see negative, let's say you get negative minus 1, it will make it same as positive 1. If you make minus 2, it will make it as positive 2. So in other words, you are just taking a mirror image of this function. So f of mod x basically means that for plus x, for all these values, it will still remain the same. This will still remain the same. This will still be x minus 1. However, right, this will basically, I hope this sketch looks basically is just nothing but the mirror image of this sketch, and this is nothing but minus x minus 1. So it will become, at minus 1, this becomes 0, at minus, so you basically replaced x as minus x in this part of the, so you just did nothing but you took a mirror image with y-axis. What will happen for mod of fx? So if now the third thing is mod of fx, right? So mod of fx means that whenever the function is negative, we will make it positive by shifting it and reflecting it with the x-axis. Here we reflect it with the y-axis, here we are reflecting with the x-axis, because we will basically make negative values of y as positive values of y. Here we will be making negative values of x as positive values of x. So we can do that very quickly. So this will be 1 here, and then we'll have something like this and like this, right? So this part will become this part will become 1 minus x, and this part has become x minus 1, and then we have, now we will have to add the values. So in this part you have minus x minus 1 plus 1 in the entire negative part, because you are adding these values. So gx will look like something like this. Let's say gx now, minus x minus 1 plus minus 1, which is nothing but minus x. So this graph will become minus x. Here this is 2, this part is minus x, right? This is 1. Then you have 1 minus x plus x minus 1. So this cancels, basically it becomes 0 between 0 to 1. So this becomes 0 between 0 to 1 here. And then you have been asked, then you can just, it is here x minus 1 and x minus 1. So if you add them, it will become 2x minus 1. X minus 1. All right. So now the final graph is here. We have the final graph here. We can clearly see that it is continuous for all x between minus 2 to 2. So it is continuous for all x. Then the function seems to have like some corner here, right? There is a corner here and there is a corner here. So it is not differentiable. Not differentiable at x equal to 0, 1. X equal to 0, 1. So I hope that this example helped you understand how we can solve problems like this. Graphically, we can very quickly evaluate the values of such functions. Now, another way to think about this problem is that because this is a slanted y is equal to minus x, the dy by dx of minus x is nothing but minus 1. So LHD at x is equal to 0 is minus 1, and RHD at x is equal to 0 is, because it's a constant, is 0. So LHD, I am writing here, LHD at x is equal to 0 is minus 1, and RHD at x is equal to 0 is 0. Similarly, LHD at x is equal to 1, because it's a constant, this is constant here, this part is constant, is 0, and RHD at x is equal to 1 is 2. Okay. So what does this mean? This means two things. A, LHD and RHD are not the same. So of course, because they are not the same, then that means that the function is not differentiable, which we can anyway see visually. And how did I calculate LHD and RHD? I am just differentiated minus x, and if you differentiate minus x, it is minus 1. You can check out the formulas videos and other differentiable videos where we do, if you do not know how to differentiate a very simple function like this, because this is a new topic, you might not be aware. So if you don't know that, please look out at the other videos in which we do discuss this. If you differentiate a constant function, it is a 0. Again, this is something which is very normal to know. If you don't know that, please you will understand that once you have looked at those videos. However, if you have something like 2 into x minus 1, the coefficient of x will become the the derivative. So you can calculate this very quickly, and you can see that these are not the same, so they are not differentiable. This also implies something else, which we discussed last time, that whenever the derivatives are finite and they may not be equal, then the function is continuous, and here they are finite and they are not equal, and hence the function is still continuous, and that is what we saw. So I hope this gives you an idea of also that you can evaluate this problem using LHD and RHD. I do believe that graphical approach has a lot of merit, so please you can still keep on trying to practice graphical approach. Now I want to quickly give you a homework problem, and the idea behind this is that you can again use this approach to very quickly do a homework problem. And the homework problem says that fx is equal to x square by 2, x square by 2 for 0, x is between 0 to 1, and then 2x square minus 3x plus 3 by 2, x between 1 to 2. Okay, and you have been asked to discuss the differentiability here. So we have discussed previously that whenever there is a polynomial, they are always continuous and differentiable. So this is continuous and differentiable in its part. This is continuous and differentiable in its part. Only thing that is remaining is 1. What will happen at x is equal to 1? And you should, again I have talked about, you should just calculate LHD and RHD, and to calculate an LHD and RHD you can just differentiate these functions and calculate the value at 1. How to differentiate these functions you will learn in things like whenever you look at the videos of formulas and basic differentiation types. Okay, so you can find, I can just give you the answer directly. The answer will show you that it is differentiable at x is equal to 0, x is equal to 1, differentiable at x equal to 1. So try to practice something like this. If you want to practice more problems of this type, it is very easy to make these problems. Just make a quadratic, linear, just write few equations of quadratic functions, and you will be able to practice differentiability, continuity, and things like that. I very recommend trying to practice problems on your own. That will be really beneficial for you to understand continuity and differentiability. I hope that you like this video. Please look at the next video, in which we will start to discuss mathematical problems for differentiability, where we cannot sketch graphs and we have to use special techniques to solve differentiability problems. Thank you.